ever get that feeling. Like research findings get presented as, so black and white.
Yeah.
But then you realize reality,
Yeah.
way more nuanced.
Absolutely. Yeah,
Like
yeah.
you'll read that a new teaching method is super effective, but then you dig a little deeper and it turns out they only tested on like one very specific group of students.
Yeah, yeah.
So what about everyone else?
Right, and that's where understanding these moderator variables comes in.
Okay.
They can really change things. So like these hidden like plot twists.
Ooh, plot twists. I like
Yeah, they just add these layers of complexity that can make those initial findings we see, a lot less straightforward.
Okay, so give me an example.
Okay, so imagine a study about, let's say, exercise and weight loss.
Mm-hmm.
And it shows amazing results, right? Everyone's losing weight.
Sounds great.
But then you find out that everyone in the study was also following this super strict diet. That diet could be a moderator, right? It's changing how those two things, the exercise and the weight loss, are related.
Oh, so it's not just the exercise alone, it's the combination.
Exactly. And that's what we're diving into today, this world of moderator variables. We're going to be focusing on a 1998 paper by a Guinness.
A Guinness.
Yeah, like the beer.
Okay.
A Guinness and Pierce. It was published in the journal Educational and Psychological Measurement.
Catchy.
And they tackled this question, this critical question: are researchers even equipped to accurately detect these moderator variables in their studies?
That's a good question.
Especially when they're working with these smaller sample sizes, which are super common in so many fields.
Right, because if you have a small sample size, those crucial plot twists, those moderator variables, they can get totally missed.
Totally.
And then that leads to misleading conclusions.
Exactly. And one of the big things that Guinness and Pierce looked at was a specific type of moderator variable.
Okay.
Dichotomous variable.
Dichotomous variable.
Yeah, so these are factors with two distinct categories, like male, female, yes, no, treated, not treated. Oh, okay, so like those choose one questions on a survey, A or B.
Exactly. And they were really looking at how these dichotomous moderators impact a statistical technique called multiple regression analysis, which is used all the time, like everywhere, to look at the relationships between a bunch of variables.
Okay.
All at the same time.
Now, for those of us who maybe don't have a PhD in statistics,
Right.
can you break down multiple regression analysis in a way that, won't make our brains explode?
I'll try. Think of it like baking a cake.
Okay, I like cake.
So you have your recipe, right? That's your regression model.
Okay.
And then all the ingredients, those are your variables. So flour, sugar, eggs, all that.
Got it.
Multiple regression lets you see how each ingredient, independently, on its own, contributes to the final product, which is the cake.
Makes sense.
But then what if a moderator variable, like, say, oven temperature, is changing how those ingredients interact?
Oh, so like a low oven, your cake might not rise properly, even if you used all the right ingredients in the right amounts.
So it's not just about having the right stuff, it's about how they all work together under certain conditions.
Yeah, exactly.
Oh, interesting.
And what Guinness and Pierce found was that unequal sample sizes within those dichotomous moderator subgroups.
So like having way more women than men in a study.
Exactly, that kind of thing. They found that that can really decrease the study's ability to accurately detect these baking temperature effects,
Wait, so you're saying that if a study has, let's say, 80 women and only 20 men, it might miss important differences in how something affects each gender?
Yeah, it might. Like, it might conclude that there's no difference when in reality it just didn't have the power to find it.
Because of that uneven sample size.
Yeah, and that has huge implications, not just for researchers, but for anyone who reads research and relies on those findings.
So then, what can researchers do? I mean, how can they make sure they're really equipped to spot these moderator variables? What are the things that influence this power when you're dealing with these dichotomous moderator variables?
Well, Guinness and Pierce, they identified a few key factors.
Okay.
And one of the biggest ones is the magnitude of the moderating effect itself.
Right.
So if the plot twist caused by the moderator is really small, it's going to be much harder to detect. Like you're trying to hear a whisper in a hurricane.
Right, so it gets lost in the noise.
Exactly.
So if the moderator is causing a really big change, it's going to be more obvious, even with a smaller sample size.
Exactly. But sample size itself is still crucial. Think of it this way. If you only ask 10 people their opinion, you might get a very skewed view, right? But if you ask 100, you're much more likely to capture the real diversity of viewpoints. That's statistical power in action. Generally speaking, the larger your sample size, the higher your statistical power. But, researchers run into limitations, right? Cost, time, just finding enough people to participate.
Right.
You can't always get thousands of people for a study.
So what do you do if you're stuck with a smaller sample size? Are there ways to, like, boost that power, aside from just getting more people?
Yeah, and that's where understanding these other factors that Guinness and Pierce identified, that comes in.
Okay.
So, for example, they found that range restriction can really mess with a study's power.
Range restriction. Okay, now that sounds kind of technical. Can you, like, give me an example, something I can wrap my head around?
Sure, imagine you're trying to, let's say, understand how experience levels affect employee performance.
Okay.
But your study, it only includes like senior managers
Okay.
who've all been with the company for like 10 years or more.
Got it.
So you're missing out on all these insights you could get from like the junior employees, the mid-level employees.
So let's say it's like you're trying to understand the whole life cycle of a butterfly,
Yeah,
but you're only looking at, like, the adult stage.
exactly. Yeah.
You're missing a big chunk of the story.
Exactly. So that limited range of experience in your study, it could lead you to make inaccurate conclusions about how experience and performance are actually related.
Makes sense.
Guinness and Pierce, they also found that the strength of the correlations between variables matters.
Okay.
Remember, we're talking about the correlation between that predictor variable.
Right. The thing that we think might be influencing the outcome,
Exactly. And then the criterion variable.
which is the outcome itself.
Yeah.
So, like, how sleep affects test scores.
Right.
Hours of sleep would be the predictor, and test score would be the criteria.
Exactly, yeah.
Yeah.
So Guinness and Pierce found that a strong correlation between those two, meaning that, they tend to move together, that actually boosts statistical power.
Interesting.
And the same goes for the correlation between the predictor variable and the moderator variable. So the stronger that connections is, the easier it is to actually detect that moderating effect.
Okay, so it's like all these pieces of the puzzle kind of fit together to determine whether or not a study has enough power to, like, really uncover those hidden plot twists caused by the moderator variables.
Exactly. And this was just a portion of what they looked at.
All right.
But the really cool thing is they didn't just identify this problem, they actually came up with a solution.
Oh, nice.
They developed a computer program that's specifically designed to calculate more accurate power estimates for studies with dichotomous moderator variables.
Wait, so instead of just, like, hoping for the best, researchers can actually use this program to figure out how much power they have before they even start.
Exactly. It helps them design better studies from the get-go.
Oh, that's cool.
So they can plug in all this stuff, their expected sample sizes, the magnitude of the effect they're looking for, all these other key variables, and the program basically tells them, hey, is your study likely to be powerful enough to actually detect this moderating effect?
That's amazing. So they don't just have to, like, cross their fingers and hope. They can plan for it.
Exactly, yeah. They can use the program to figure out, how many participants they actually need,
Okay.
how they can maybe adjust other study parameters, and ultimately that helps them increase the chances of getting reliable, accurate results.
So this is, like, a game changer for researchers.
Sure.
Especially those working with smaller sample sizes.
Oh, yeah, absolutely. And to make this tool super accessible, they wrote the program in Quick Basic,
Okay.
which was like this very common programming language
Yeah.
at the time, so people could use it on like standard computers. Most researchers already had those.
That's fantastic. So
Yeah.
they weren't just interested in, like, creating this fancy tool.
Right.
They want to make sure it was actually useful.
Exactly. And it really had a lasting impact.
Yeah.
Their paper and the program, they've become like essential resources,
Cool.
helping researchers in all sorts of fields conduct more rigorous, reliable studies.
Okay, so we've covered a lot here. We've talked about the basics of what moderator variables are, how they impact statistical power.
Right.
We've even talked about some tools that researchers can use to, make sure they're accounting for these plot twists.
Right.
But, like, what does this all mean for our listener? Like, for someone who's not a researcher, how can they use this knowledge in their everyday life?
That's a great question. I think the biggest thing is it's about developing a more critical eye when you encounter research findings.
Okay.
Whether it's in, a news article or a scientific study or even just like a marketing claim.
Right.
Don't just take the headlines at face value.
Be like a detective, look for the clues.
Exactly.
Okay.
Ask yourself, was the sample size big enough to actually support these conclusions?
Right.
Were there any potential moderator variables that weren't even considered? Could those be influencing the results?
Oh, that's such an important point.
Yeah.
We need to be more discerning. We can't just take things at face value.
I mean, keep in mind, we talked about dichotomous moderator variables today,
Right.
which are like one piece of the puzzle. There's a whole universe of other types of moderators out
Oh,
there.
so that's a good point. We've only scratched the surface.
Think about continuous variables,
Okay.
like age, income, where there's a whole spectrum of possibilities. It's not just two categories.
Right.
Or categorical variables with multiple levels, like education level or ethnicity.
Okay.
So these types of moderators, they can influence findings in even more complex ways.
So this deep dive is really just the beginning
It is.
of a much larger exploration.
Absolutely. And I think that's what makes this so exciting.
Yeah.
By understanding these nuances, we become more informed consumers of information.
Right.
We're more empowered to make decisions that are based on solid evidence.
I love that. So it's about equipping ourselves to actually think critically,
Yes.
not just passively accept what we're reading.
Exactly.
Ah.
So as you go about your day and you see research findings, remember to ask yourself, what are those potential moderator variables? Could they be shaping those results in ways that, aren't immediately obvious?
What a great takeaway. I feel like we've given everyone this decoder ring for the world of research. Guinness and Pierce's work is so important. I mean, it reminds us that these concepts, these ideas, they're not just abstract. They have real world implications.
They do for how we understand and apply these research findings that we see.
Exactly.
Yeah.
Yeah, it's like we've, peeled back the curtain, right? Shown people all the behind the scenes action that goes on, and we're trying to produce research that's actually reliable. And once you understand that, it helps you make better decisions in all areas of life, really.
For sure, yeah. I mean, it's really about empowering yourself to be a more critical consumer of information, to be more discerning, because we see these research findings everywhere we look, right?
Yeah.
And knowing
Yeah.
how to evaluate them, super important.
Absolutely. So as we wrap up here, let's go back to that key takeaway. What's the one thing we want our listeners to remember from this deep dive, this whole world of moderator variables?
I think the biggest thing is just because a research finding gets presented in a certain way, doesn't mean it's like the whole story.
Right.
There are often these hidden factors, these moderators, lurking beneath the surface that can really influence the results in ways that at first glance you just don't see.
So don't just accept things at face value, right?
Right.
Look deeper. Look for those plot twists.
Exactly. And remember all those key things we talked about, the things that affect a study's power. So sample size, of course, bigger is usually better.
Right.
The magnitude of the effect, how strong are those correlations between the variables involved. All these pieces matter when it comes to, how confident we can be in the findings.
Yeah. And it's important to remember that what we talked about today, that's just one type of moderator variable.
Oh, for sure. Yeah.
There's a whole world out there.
Yeah, absolutely. All these different types of moderator variables, and they can affect research findings in all these complex and fascinating ways.
It really is a field that, is ripe for exploration. Maybe one of our listeners will be inspired to, do a little more digging themselves, uncover some new insights.
I hope so. I love that.
Well, on that note, I think we're going to wrap up this deep dive into the world of moderator variables and statistical power. Huge thanks to Guinness and Pierce. Their work is so important. They gave us these tools to become better, more critical thinkers.
Couldn't agree more. Really enjoyed exploring this with you.
Me too. And to our listeners, keep those critical thinking hats on, and we'll catch you on the next deep dive.